lesson, I'm going to go over two methods of factoring, and you are seeing all four methods on this cover unit here on factors. The first method is called GCF, or greatest common factor. The second method of factoring is differences of two perfect square, and we sometimes call it dots. Factor by grouping and factor the trinomials. You are learning the first two methods in this lesson video today, factor by greatest common factor and factor dots, or factor differences of two perfect square. Before I go into the lesson, I just want to point out the image that you see down here. Factor is when you are looking for something that gets to multiply and you get the questions. So when you are asked to factor, this is the answer that you get. Something in green over here, the first parenthesis, multiply in another green parenthesis over here, multiply it, and you can get back to the question. That's how you can check your answers. Did I multiply? Did I get the correct answers? You just have to multiply it in. X times x squared, 5 times positive 3, that's negative 15. And then remember the smiling method to check the middle number. You can always review the previous video I made on the smiling method to check these answers. Before I begin the lesson, I did go over the use of factoring before when in earlier videos, but I also want to point out, when you're in doubt, you can always ask Google nowadays, right? It's very convenient for you. The information is at your fingertips. This is what I did. I type in algebra factor in real life, and I get a tons of people ask and people answers, and you actually see the professional in the field of work that answer you. This is what are some real life application of factorizations by Quora. I found this to be very interesting. You can click and get the answer by different people on your own. You instead of just hearing it from your teachers, you can actually hear it from someone else other than your teachers, right? And you will be able to find real life application of factorings, and many professional who are working in the career, with and how they use it in their life. You can see the answer for yourself. Now let's get on to the lesson. This is the Jamboard, and we are showing you the greatest common factor on the left, the dots or differences of two square on the right hand side. So you will be able to read this on your own in details later. I'll just quickly skim through the information here, or the notes here. So first, determine if a common numbers or variable or letter, the greatest common factor exists. And you may also use the factor trees to factor the difficult numbers. So we are showing you an example of the factor tree on the left hand side on this green post-it. We are showing you how to write it horizontal method to find the greatest common factors. Most of the time, this is the note or on scratch paper that you might also do. And again, the factor tree in the problem itself. Now, the greatest common factor we will show you in the example, and you will see how it's done. This is just the notes that is for your information. If you're interested, you can always read on your own later. The differences of two square, we want you to see this silly man that has the, what is this, horoscope? Okay, be on the lookout for two perfect squares and a minus sign. Okay, so be on the lookout, two perfect square, x squared is x times x, that's a perfect square, right? 36, what times what? Yeah, 6 times 6 make 36. Perfect square is just a number multiply itself. And it said right here, down here, it said If there is a minus sign, you can factor. Is the minus sign that causes the middle x to cancel out. So the middle terms get canceled out when you actually multiply this in, and that's why you get that answers. So the positive and the negative will create the middle terms that cancel out each other. Now, down here, don't skip this note, even though it's on the bottom. It said beware or caution. Two perfect squares and a plus sign are not factorable. Okay, so when something is not factorable, you can put prime. And that's the word to say not factorable. Let me go ahead and type that in right here. So this is the word prime. Let's make it red. And we will see if we can make that red letter. Okay, so prime is the word when something is not factorable. You can also write not factorable as well, but you will see that on some of the questions on SAT or college entrance exam, they will use the word prime and not factorable. Now let's get on to the example that we have for you. We will do some of these problems. This is your work assignment, and we will do some of these problems as guided practice for you. So let's go ahead and start with number 1. Oh, I'll go ahead and use blue. Okay, so our number 1 is set GCF, greatest common factors, right? So the greatest number that can be drawn out of 16 and 4. What would be that number? Well, I would say, well, 2 or 4, right? Because 4 is the lowest number over here. And I see that the 4 can be divided into 16. Then that's what I would put down first. 4 is the number that I can draw out from both, which means that I will just go ahead and divide 4 into this one, and it's divided. I will get no remainder. I can divide 4 into 4 and I will get 1, or it's dividable. it's it can be divided into 4. So 4 divide 4, I get 1, right? That is why I would write the first greatest common factor or numbers is 4. Now, P, how about the letter P? We have P in both of these terms, and I have 4P on the first term, and I only have 3P in the second term. So the highest number of P I can take out from both terms is 3. And that's why I wrote 4P cubed, or 4P to the third power. That's how you read it. And that is our greatest common factor. Now, there is one more thing I want you to do though. You gotta create a factors that multiply this 4p cubed to get back to this problem. So what do? We are going to see what can multiply to get 16. You can say 16 divided by 4, I get 4, right? Or 4 times 4 is 16. So inside this parenthesis, and I'm going to get 4p because p to the third power plus p to the first power will give me p to the fourth power. So you can review the rule of exponent if you're not sure how we get this p to the first power here. But basically we add the exponent when we have to multiply the same base. Now p to the first power, I can just go ahead and take it out. The plus sign, I will use that because I do want to write it in a way where I can multiply and get back to the original problem. So what I get right here is I divide 4 into 4 and I get 1. and p to the third power is taken out. So like it's like, you're dividing 4p cubed into both side, but we didn't write a p in here at first because we didn't want to make it, like complicated. So now I'm dividing this into 4p cubed. 4p cubed divided into 4p cubed, I get just 1. Okay, so my answer for here will need to be a 1. I do need this number. Why? Because to check the answer, remember we said factor is something, and that something is the 4p cubed right here. That something is the 4p cubed right here. We are multiply with something else, which is this parenthesis of 4p plus 1. And if you can multiply these two factors and get back to 16p to the fourth power plus 4p cubed, then this is your correct answers. And that is how you can check and make sure that your answer is right. Just multiply it back in and you get the question that we break off by factoring. Now let's go ahead and try one more problem. Let's go ahead and pick number 5. Okay, so both of these in number 5, both terms have negative. So what I will do is I will go ahead and take our negative. And it looked like, hey, both of them have 6. So why don't we start with negative 6? Now the letter. How many letter of R can I withdraw from both of these safely? Well, I have 5R and then I have 4R here. So the highest number of R I can take out from both is R to the fourth power. Okay, so negative 6R to the fourth power is the greatest common factor. And remember, the word factor here can be a number, can be a letter, right? And it can be both, like here, negative 6R to the fourth power. That's the greatest common factor of both of these. Now, what you're going to do is you're dividing this into both of these terms and see what you're left, and you're going to put what you're left with inside a parenthesis. So we are going to have, and I usually like to say, okay, what do I multiply to get this? Because I'm better at multiplication than division. So that's why I don't write, the division like this one, but I usually say, okay, what multiply this will give me negative 6? Well, it's going to be 1 because 1 times negative 6 is negative 6. What multiply r to the fourth can give me r to the fifth power? Well, then that would be r to the first power. And remember, number 1 I don't have to write down, so I'm going to change this into r. Okay, r to the first power, I can write a 1 in, but I don't have to write a 1 because it can be an invisible number. And this is one of the flashcards that you have, invisible number 1, right? So r times r to the fourth power, I add the power and I get r to the fifth power. Now, the sign in between, you have to be careful because you withdraw a negative. So this negative, multiply a negative, will give me a positive up here. And I don't want a positive, I want a negative. So what that will be is that I will change this into a plus. And that way, if I multiply a negative with a positive, I will get the negative. And what do I need to multiply to get back over here? Well, this is negative 6r to the fourth. This is negative 6r to the fourth. I just need to multiply a 1 to get exactly itself. Okay, close the parenthesis. I'm done. And remember how we checked it? We just take this factors, which is negative 6r to the fourth, multiply this factor of r plus 1, and if we get back to this original problem, then your answer is checked. Let's try problem number 14. Okay, we have done 2 odd problem, now an even problem, and for some reason people always claim the last one is hard. So we will try number 14 together. Okay, so now I have 3 terms, and remember 3 terms is called trinomial, right? 2 terms is called binomial. We factor binomial, and now we factor the trinomial. So always, when you're asked to factors, try to always look for the greatest common factor first, no matter which factoring method you're using. So here, I'm looking at all three terms. I'm looking to see what I have in common, a number of letters, maybe the sign. If this is, all negative like number 9 here, then that's what I will take out first. Maybe a negative something, okay, a negative number. But hey, let's not get distracted. We're working on number 14, and I'm going to try to zoom in on number 14. So all of them, okay, this one negative, this one positive, positive. So we cannot get our negative here. But all of them have, hey, maybe 10, because I have 50, 50, 20. I can probably take 10 out of all of these numbers. Okay, so then what that means is I'm going to divide 10 into 50, 10 into 50, 10 into the negative 20. And then P, this is the letter P, but it's being blocked by the red box down here. So P to the third power, P square, no P. Okay, so this is P to the 0 power, and that's why we did not write it in, no letter in there. So I cannot get our letter P because this term does not have the letter P in there. So only the number 10 is the common factors, the greatest common factors. And we will see if we are done after we divide out the 10. So 10 multiplied 5 can give me 50. And I do want P to the third power, so I'm going to write P cubed. Okay, so this multiply this will give me these terms. Next, we add because of this sign. And again, it's 5 times 10 give me 50. And I want P squared, so this is going to be P squared. I write it in here. Next, divide 10 into negative 20, or you can say 10 times what make negative 20? That would have to be negative 2. 10 times negative 2 will give me, 10 times 2 is 20, and I have the answers. Okay, so when you're done with this, you know that 10 is the greatest number that you can withdraw, because look at this. I don't have any more common numbers or letter. Then I'm done. Okay, I can check my answers just by multiply it back in, and I need to get back to this original problems to check the answers. Okay, so 10 times 5, and P, the letter P also follow along, and you just keep doing that, multiply it and get back to the problem, and that's how you can check your answers and see if that is correct. Now I want to do some problem on factor the differences of square as well and show you. This is one of my favorite, and I'm going to go ahead and change the color so that it can be a little bit different than the one on the left hand side. We can go ahead and use red. Okay, let's use red. Okay, factoring the differences of two square, we're looking for the differences. So these are minus sign, you see all of them, okay, except for this one. Okay, and this one is where we are going to say prime, remember, not factorable. Okay, so let's go ahead and write that in. Prime or not factorable, you can use either one of those terms. Again, if I get a plus sign, they are prime or not factorable. Okay, so you can type in not factorable, but usually I just, use the word prime. And that's the answer when we cannot factor something. Okay, now differences of two square. But remember, to be able to factor using this method, you must have a subtraction sign, the difference. That's what the subtractions, another word for subtraction sign, difference. Now, we're looking for two perfect square, or a number or a letter multiply itself. And in this one, let's try number 1. 9x squared minus 1. What is it? Yeah, you can use the uh, factor tree method, like this one. What time what? Yeah, it's 3x, right? Time 3x. Okay, it gotta be multiply itself. That's how we call it a perfect square. What about 1? 1 would be 1 times 1. 1 times 1 is itself. So the answer here is very easy. I can just go ahead and write 3x plus 1 and 3x minus 1. Now, if I put 3x minus 1 first, it doesn't matter. And then the next one, you just have to put 3x plus 1 in the second one. Okay, I didn't do this very well, so I'm going to go ahead and type it in later. Or maybe right now. Okay, so 3x minus 1 or 3x plus 1 first, it does not matter. Okay, we have to make this a little bit smaller. And we do want it to be on the same line. Okay, what matter is that you have a plus and a negative, so that way the middle term cancel out. Again, the same thing. You are going to multiply it back in, and you get the questions that you begin to factors. Then that's how you can check your answers. 3x times 3x, 3x squared. 1 negative times positive 1, we get negative 1. And then the middle term is going to be negative 3x and positive 3x. The middle term cancel out each other. That's how you can check your answers and make sure it's correct. Let's do a few more questions. Over here, I get 4n squared. What would be the number and letter that multiply to get 4n squared? Yeah, it would be 2 times 2, right? Or 2n times 2n. That's how I can get 4n squared. What about this negative 7 and positive 7? Or negative or positive? Well, okay, both. Okay, 7 times 7, we get negative 49. We need, remember, a negative and a positive. So let's go ahead and put it in. 2n. Okay, I put negative in the first one, so I'm going to try to put positive first in this one, just so you know it doesn't matter which one you put first. 2n minus 1. As long as the sign are different from each other, the middle terms cancel out. This is the answer we will get for the second problem. Oops, I missed the first parenthesis over here. Okay, 2n plus 1, 2n minus 1. And you can always check by multiplying it in and see if you can get back to this problem, 4n squared minus 49. Let's try another one. Okay, let's take a problem that may look slightly different, like this one. Okay, number 9. Let's take a look at number 9. 150k squared. I know k times k can give me k squared, but 150. I don't have a perfect square here. 216. I don't think I have a perfect square here. What you can do when you are looking at problems, remember we mentioned before, you gotta try to get the greatest common factors and factor it out first before you can factor this differences of square. It will be clearer after we factor out the greatest common factor. So here I know that I have something in common because both of them end with a 0 and a 6. So I know I can divide out a number that would be in common. Now, this is something that you can work out on scratch papers. if and it would really help if you can, do the factor tree on the scratch paper. Okay, so I strongly recommend that you write this out here somewhere where you have more room. 150, I know I can take a maybe 6, maybe a 5. Okay, so divide 5 into 15, I get 3. And divide 5 into 0, I get 0. So 5 times 30. Okay, 30, I can still do a 5 times a 6. Okay, so this is what I do to see what number they both have in common. Again, we can go ahead and break out the 6, but let's try to see if we can get the answer by breaking off the 216 here. Okay, 216, I know a 3 can be divided in, or a 2, but we will try the higher number. So 3 times 7 will give me 21, and 3 times 2 is 6. So 3 times 2 is 6, 3 times 7, 21. And this 72 right here, I can still break it off by dividing a 2 into it. Okay, so what would that be? 2 times 3 is 6. And I subtract 6 from 7, I get 1. And that makes 12. So 2 divided into 12, I get 6. Okay, it's 36. I can get 36 is 6 times 6, right? But you see, I have something that I can take out in common already. I'm going to go ahead and use red to circle that for you. Okay, I do see that I can withdraw the number 6 from both of these. And that's what I'm going to begin. Okay, I'm going to go ahead and write 6. And then I can begin to see what I can factor out. So let's go ahead and write it here. Because this is not going to be the final answers. Okay, 6 times what make 150? That would be times 5 times another 5, that's 25, right? Okay, 6 times 5, 30, hold 3, 6 times 2 is 12, 150, yeah. Now we are going to get the k, and the k is not something that they both have in common, so I have to just write k squared right here. The minus sign, 6 times what number give me this 216? That would be 36. And I can double check my answer by multiplying it in. 6 times 6, 36, whole 3. 6 times 3, 18, 19, 20, 21. Yeah. Okay, now you see, we factor out the greatest common factor, which is 6. And we have the differences of 2 square inside this parenthesis. And we have to continue to factor this part out. Okay, and the final answers, I'm going to go ahead and type it in. The final answer is going to still get the 6 on the top. And it will be 5 times 5, 25, right? 5k minus 6 and 5k plus 6. Okay, we do have to make it smaller to fit this box. Okay, this is our final answers right here, down here. Okay, the 6, just follow along into the answers. This perfect square is broken apart to 5k minus 6, 5k plus 6. And this is how we can check our answers. We multiply this, multiply 6, and we get back to here. Another one? Okay, let's take a look at this one. Same thing, greatest common factor, factor it out first, right? If we don't see the perfect square in there, Remember, I mentioned before, any type of factoring method, you might have the greatest common factor in there that you have to factor out first before you begin to see the differences of two perfect square in and then you can use that method. So here I see that I have a 5 that is in common right here. I'm not going to do this one because you can do it later, but I can go ahead and put the 5 in. It didn't let me type earlier. Okay, I think I know what I did. I need to actually select this arrow and then I can type it in here. Okay, now it let me type. Okay, so withdraw the 5 out first, right? Something minus something, and you have to find the answers. And remember, you can still factor it, then you need to still factor it like I show you over here. I think I moved this a little bit. No? Okay, let's put it back. How about this one? Yes, you can still factor something first before you will see the differences of two perfect square. What is it that these two numbers that have in common that you can withdraw first? A 3? Yes, 3 can divide into 75, okay? How about this one? Maybe a 2, at least a 2, but for number 12, I think we can actually get 6 out of both. 6x. Look, both of these terms have x. So I know that you can factor out a 6. Oops, I want to type that in, but it doesn't let me. So let me go ahead and reselect that. Oh, now 6x is the common factor. We need to do that first. And then write down what you are left with. 4, right? And minus, what would that be right here? Okay, I just want to type the frame in and you want to go ahead and finish this work, right? We show you part of the answer already. The 6x is going to be part of your answers. And I feel like after you write the number that replace these question mark, you can still factor it using the difference of two squares. Okay, so some of these problems we have to factor out the common factor and then you will be able to use the difference of two squared to factor it, just like how I show you in number 9. Okay, let's have you practice and remember to check answers when Ms. Nong posted during class. Have fun!